Good evening, students. Is everything clear? My voice audible? My screen is visible? I've not shared my screen yet, but just let us check these things. If everything is fine, then let's give them 3 more minutes. We'll start at 5:45. Meanwhile, I'll share my screen and show you on which model we are going to work today. Meanwhile, please grab the image of that or take a pic of that so that you can refer that, okay, while modeling. Let me share my screen. Students, please take a pic of this or take a screen grab of this so that you can refer it, okay. We'll discuss and do it. Just go study this drawing, this ISO view, okay. And today you are going to tell me the dimensions. You're going to study and tell me dimensions, and I'm going to do the model, okay. And also, because we have already covered almost 4 models we have done, okay. So by now I think you people understood the process what we are following for the best practices also we discussed, okay, along the model. While doing the model, we also discussed about the practices, the best practices. So you are aware of that also, okay. So today I'm going to ask questions, okay. Let it be an interactive session. Let's just discuss and do this, okay, so that you people can grab more out of this. Okay, so took the pic. So I'm changing my screen now. Present now. Okay, I'm changing my screen. So is that okay? Shall I change the screen? Have you grabbed it for your reference? Once again, I'm just maximizing the view so that you people can take it. Again, this is the machining part, okay. But the methodology will be different for this part, okay. So as you practice, then you can understand. Once you study the drawing, study the type of model, then you will come to know what process you need to follow and how to select the front view, how to select the top view, etc. So everything you will understand. Okay. Okay. So I'm changing my screen now. I'll share a different screen. Catia screen I'm sharing now. A moment, please. How many have joined now? Okay, so how many of you have joined now? Let's have a look. Okay, let's start our model. Okay, so one response, please. Is my voice audible? Is everything clear? Is the screen visible?
Yes, sir. It's
Okay, good.
visible.
So let's start now. So, so guys, I'll be asking you questions. Okay, please guide me for the dimensions. I'm going to model this based on your input. Okay. Now let's see the drawing. Okay. So please refer the drawing. So today's model is again a machining part. Okay, and it's isometric view given, and the dimensions are given. A simple part, not very difficult, but methodology is a little bit different. And you are going to learn new commands today. Okay, how to create the rigs. Okay, that you are going to learn. And okay, students, which is the front view here? What do you think? Which is the front view? Any answer? So actually, there are things to be considered. Okay, when if you are working in a particular project, as I mentioned, so it depends on the customer. there's regulations and rules how to decide the front view, how to decide the rear view. But as we are not working under any particular standards, so if you get a simple drawing like this, okay, when you look at this, what do you think? What is the front view? So always I'll tell you on basic rule for front view, but what is your answer? What is your opinion on this? Any answer? Okay. So in this drawing, simply they have given an arrow direction. Can you see this? Arrow direction. Okay. If this is an ISO view, okay, then the arrow direction is given that this should be your view direction. Okay, that means you can consider this as front view. And one more simple, if nothing is given, if no details are given, then you can consider the front view as the view in which maximum details are available. Maximum details, for example, in this view, if you see, this is ISO view, and which is the view where you can see maximum details. Details in the sense, the maximum features details are available. That means if you see the,
Sir,
because he has already given here
sir,
arrow mark.
so we can't see your screen, sir.
And see, can you see my Catia screen?
Yes.
Yes, sir. Catia screen you are seeing, sir.
So I already shared this drawing actually. So you have not taken the pic of this.
No, sir, can you show it once?
Okay, I'll share it again. Take the pic of that. Some of you
Okay, sir.
they took the pic of this and they're referring the drawing. Okay, so if you have not taken, I'll share it again, and please take the pic of this. I'm stopping now. I'm sharing it again. Can you see it?
Yes, sir.
Yeah, please take a pic of this. If there's a laptop, or take a screen grab, or desktop, you can take okay, print screen. Simply you can take print screen and copy it on a PPT and keep it with you, or if it is a mobile, you can take a screen grab of this and just keep it, and we'll discuss about this. Okay. Okay, so as this is on the screen, let's discuss first. Okay, because in this image, guys, is that clear? One response, please.
Yes, sir.
Good. So if this is arrow direction is clearly given, okay, so we don't need to think about the front view or rear view. So directly we can take this view as front view, and then we can go ahead. Okay, we can consider this as front view. Okay, so this gives you the orientation of the so to model a part. Okay, so what all things are required as input for us? So which plane has to be selected? Okay, we have planes, and that is our first question. So which plane has to be selected? How to decide that? Based on the input. Okay, so what is the front view and which direction this should be projected? The part should be projected. Okay, these are the questions you should get. And what are the uh, coordinates? Okay, initially maybe it is not required coordinates. You can just do it at 0 0 0, but later on if they want to change the coordinates, then you have to see what are the coordinates, and you also keep the coordinates as per the input. Okay, so as of now we are not going to look into that, but make sure that your part is moving. That is also one requirement. Okay, and that's why I've been sharing best practices to make sure that the part is moving even after completing the part. So many times the part won't move. That's because you have links with the other parts. Maybe the other features sketch is linked with the 3D somewhere. If you project the line or some reference surface from the 3D, then that will be linked to that. In that case, that's not going to move. Okay, and if the sketch is not completely constrained, then also it's not going to move. Okay, so that's the main reason you need to uh, constrain the sketch completely so that the model also can move easily. Okay, so I'll show you why it is why it won't move. You constrain in the sense you're completely uh, creating a link with the axis. Okay, and the coordinates are related to the axis. Okay, when you double click on the center of the axis origin, okay, then you can change the coordinates that I already showed you. Okay, so that means we completely the sketch is connecting. We are connecting the sketch completely with the with the axis only, not with the 3D some other solid model. Okay, or some other reference model. We are not going to. We are projecting it for our reference, but we are isolating it. Hope you remember that option. Okay, command isolate. That's the reason we isolate with the other solid models, and then we link it with the axis only so that it can freely move. Okay, just remember that. And in this view, if you see what is the front view, this is the front view. And in general, if you see, most of the details are available here. So what all details you can see here? The length of the part you can see, width, okay, and this 62 width of the part you can see, okay, and then you can see two holes here, and details of the holes are given here. That also we can see. Okay, thickness of the pad we can see, the thickness of the part we can see, and also thickness of the ribs are visible from here, from this direction. Okay, maybe if you from front view you cannot see this thickness and this thickness. Okay, this is visible only from side view. Okay, side view, what all things will be visible from side view? This 50 this will be visible from side view. 18 14 that is the wall thickness. Okay, this rib thickness will be visible from side view. This thickness, this distance, that is width of the part, will be visible from the side view. Okay, but from front view, this you can see the front rib thickness 14 you can see the whole details. Even whole details are not visible actually, but only you can see the hidden lines of the hole from a thickness. Okay, and from that also you can find out the dimension. One dimension you can find out from here. Okay, and the dia of this cylindrical part which is mounted on the top of this. Okay, this part also details, inner diameter, outer diameter, you can see that. Okay, so if you check most of the details you can see from the front view. So this is how you need to check when you receive a drawing. Then you need to check which is the view where I'm getting all the details. Okay, and then you start considering the start modeling it or start creating a drawing using that view. Okay, that is a basic rule actually. Just remember it. But uh, project to project or customer to customer, it varies based on their requirements. We have to work. Okay. Okay. Let's go back to Katia. I'm stopping this. and I'm going to share my Catia screen. Okay. Guys, can you see my Catia screen now? Is that
Yes, sir.
visible?
Yes, sir.
Okay, good, good. Okay, so let's go back to a drawing. Okay. So what drawing says? So we have a pad. Okay. Please refer the drawing. We have a pad. Okay. So initially, previous models, how we did it, because it's a machining part, and even this is a machining part. But if you follow that process, you may not achieve this part. Okay, you may not be able to complete this. So how to complete this part? So because these are the grips. Okay, so while using these commands, so what kind of process means how we have to use these commands? Based on that, we have to model it. Okay, so first, to model this, first I need to complete the base. Um, we can say the base of this part. So base of this part is around thickness is 16 mm. Am I right? Right side, you can see on the right side of the part, 16 mm is given, and the width of the part is 110, and 62 is the depth of the part. Am I right? Let's start from there. And as I mentioned, so we are going to take our front view. Okay. So where to consider? We have a toolbar here, which will show you which is the ISO view, which is the front view. Guys, can you see this? Remember this. This is very important for you. So this tool will show you which is the front view, and based on that, if you want to change, you also can change it. You can edit that. Okay, that also I'll show you how to do that. Okay, so I considered front view, and let me see in front view, is it possible? So this is my front view, so I should get in YZ plane. So my front view is YZ plane. Okay, default I have considered here in Catia. YZ is the default front view, but to create this pad, how do I need to proceed? So this is my YZ plane. Okay, the direction of this arrow is YZ. Okay, YZ, but I need to create this pad. To create this pad, from where it will be easy for me, either from here you can create.
Sir, see me, sir.
Any question?
Yes, sir. Can you just open that drawing in the window, sir? You used to open it.
Sorry, it's not clear. Can you please?
The drawing, sir. The drawing. Can you just open it in the window, sir? Sometimes you used to show it like that also, right? It will be easy, sir, because we can't close and see it again on the phone.
Okay, let me open it. So you want to open it in another window, right? Just a moment. I'll save it as zip file or something, and then I'll share it.
Sir, in Catia itself, it comes right in Catia window option, sketch and drawing.
I'll try to do that. Yeah. Just a moment, yes. I'll show. Point. Anything visible?
No, sir, it is black, sir.
It's not converting. Yes. Just a moment. Huh? Just a moment, yes. I'll just capture this. Try to show you the not converting. Try once again. Yeah. that visible, guys? Can you see it?
No, sir.
No. So drawing. Can you see my drawing sheet here?
Sir, your screen is not shared, I guess.
Yes, you have not shared your screen, sir.
Okay. I'll show you. Huh? Can you see it?
Yes,
Yes,
sir, now
sir.
I can see it.
Okay. And let me. Now, can you see the screen which is showing part workbench also?
Yes, sir.
Okay, good. Now both are visible, I think. So this is our drawing. Okay. Hope now the dimensions are clearly visible. Okay. So now let's about this. So I'm talking about this part. Okay. So this is our front view, and so in our default, in our part model, if you see which is the front view, this is the front view. Okay. If you say front view, it is showing ZX plane. Okay. So ZX plane here, if we compare, this is our Z and this is our Y, right? This is ZY plane. Okay. So this is our Z and this is Y. Okay. This center, if you consider this as Z and this will be your Y. Okay. So now to model this, either you can start from here, okay, or from the top of this. Okay, let's consider this portion. Okay, what is the dimensions of this? Please let me know so that I can model it. Okay, I want only this portion. Okay, this portion, thickness of 16 mm and width of 110 mm, and how much we need to project that we will see 62 mm. Okay, I'm starting from here. Okay, because I have considered this as front view, so I'm trying here. You can model it from here also, or else you can model it from top view. If you see this complete rectangle, you can start with. Okay, you either you can model this or this. Okay, but from front view I'm considering this, so let me start with this. Okay. Okay, so just let me know the details of this so that I can model it. Okay, this is my front view. Guys, you understand it, right? I'm not going
Yes.
fast. I'm very slowly I'm explaining, okay, so that you all can understand. So slowly, let us get into Sketcher. How to get into Sketcher? Select the plane which you want, okay, and then always go to position sketch, and then check your orientation, vertical and horizontal. If you want the same orientation, then you need to keep this vertical and horizontal always intact. Okay, say okay. Okay, now so if I consider this one, then we are going to miss one thing here. Plane will be considered here. Okay, then we will do one thing. Okay, so we will consider this as the axis. So as I said, we need to consider one portion as the axis. Okay, the very important portion. So here I believe very important portion is the top one, this one. Okay, some part is going to get assembled here, and it will be kind of some a rod or some shaft will come and sit here. Okay, so for me this portion must be uh, perfect. Okay, so that's how we can consider our axis here, or else we can consider our axis one of these holes also. Okay, remember this is very important. When you have hole kind of things, then we consider that this hole, theoretically we consider that this is perfect. Okay, and these are very important holes, because this has to be manufactured with precision, and there will be deviation. Okay, based on their requirement they are going to give you plus or minus 0.5 or plus or minus 0.2, but that will be allowed deviation. Okay, so that's the reason either we have to consider this or this or this. Okay, if you have no holes, then we have to go for the flat surfaces. Again, what is the rule for the flat surfaces? The flat surface which is coming in contact with the other flat surface, where this if this flat surface, for example the base of this flat surface, bottom of this flat surface is getting welded with another part, then theoretically we need to maintain the surface roughness. Okay, we need to control the surface roughness as per the requirement given by the customer. So here, because we have holes, that's why I'm going to consider one of these holes as my axis. Okay, origin. So the best thing is, let's consider in front view this is visible, so let's consider this as axis. Guys, is that clear what we discussed now? For every part I'm repeating this. Okay, so these are the basic rules for modeling. You can model it anyway. Well, you take one drawing and do it. Okay, but you should know the theory. Okay, theory part is, these are the basic rules. Once you are working on some particular project where things are already defined, so the OEM will already tell you, no, I want this as center, this as origin. Okay, this part is coming and sitting in this orientation, so you need to consider this point as origin, or your axis should be here, and your orientation should be this. So if they define it, then you have to follow them. In such cases where you don't have any information, then these are the important things you need to consider. Okay, clear guys?
Yes, sir.
So based on this, let's consider this as my axis. If I consider this as my axis, that means, so this point is this point. Got it? Clear guys?
Yes, sir.
If this point is this point, then what is the dimension of this, where I need to consider this? Okay, so roughly let me start with this. Okay, I'm going for construction element. What is the best practices? You should not directly click on this. Okay, this is not this is not good, directly creating on the origin. So you need to use, so I took this circle here, and then I created one circle away from this origin, and then I select this center and the origin, and I'll say right click, and I'll say coincide. Now it is coincided, and I need to control outer dia and inner dia. Okay, so I'll take only one dia here. Okay, let us 40. What is the dia of this outer dia of this cylinder? I need answer from you guys.
44.
44.
44. Okay, so this is 44. So why I'm doing this? To define this point. Okay, to define this point, I'm doing that. Okay, and see, this is how to calculate this. This is 62 mm from here, from this point, and from this wall, from the edge of this, how much is projected? This cylinder is projected. How much it is projected towards front view? Please calculate and tell me. I need this point. I need to keep my origin here. From here, from this point, what is the distance I need to maintain for this? That I need.
So 64 plus 16.
Yeah.
80.
So this, okay, this thickness, this. Am I right? 18 plus 14. Am I right?
No, sir, we are looking from the front view, right?
Yeah. So I need to define this. So if I take axis here, what is the distance between this face, okay, this face and this face? You calculate and keep. Once we enter this add creation, then we need that dimension. Okay, we are now
Okay, sir.
this portion as my axis, and I'm going to simply create this. Okay, and what is the height of this? From here it is 64. Okay, from the center of this up to here it is 64, and from down it is 16 mm. Okay, I'm going to create simply a 16 mm pad here. Thickness of this is 16 mm. Okay, guys, and now is this exactly at the center? This is 110. Okay, so this is exactly at the center, isn't it? This is the axis.
Yes, sir.
So this is 48. Okay, 48, and let me maintain this as 110. Okay, let me maintain this as 110. Okay, this with how much? 110 here, and this line and this line must be symmetrical to the axis. Now my both these lines are symmetrical to axis. Okay, how to do that? Again, I'm doing it. Select this line, left side line and right side line. It should be symmetrical to this line. Why? Because they are exactly at the center. The axis is exactly at the center of the part. So that's the reason I need to keep them symmetrical to the axis. So I will select here symmetrical and say okay. Okay, now this is exactly at the center. Okay, now I have maintained the thickness here. Okay, and it is exactly at the symmetrical to the axis. Okay, now I need the height of this. I need to maintain this height. As per this, from here to here it is 16 mm. It is 64. Okay, am I right? From the center here it is 64. So I'm maintaining from the center to this top edge as 64. And now this is my construction element. I don't need this. I only need this. Okay, so I'm creating only the pad. So I come out of this sketcher. Now I need to, so my sketch is exactly at the center. So now I need to check. So this is my center, okay? From this wall it is at this distance, 14 plus 18, okay? So from here, the total width of this is 62, okay? 62 minus 18 plus 14, how much is that?
30, sir.
30, okay? So this distance is from here to here, it will be 30, and total it will be 62. Once you come here, select this. It is saying the current and work object. You always say yes, and it will get into this part body, okay? Now, this is the part, okay? Say more. We have two limits here, okay? So first limit is from axis to towards front, okay? So how much is this? 30 minus 62. Am I right? 62 minus 30, isn't it?
No, sir. It is 62 minus 32.
62 minus 32. 32.
Yes, sir.
This is our front portion, okay? Front dimension. And how about rear dimension? How much is that? It's 32.
32, sir.
Okay. Now pad is created. Got it, guys? In such cases, you have to use this. So where you have considered the axis, you have considered here. And what is the distance here? Total is 62. So our axis is at 14 plus 18. So pad will be 14 plus 18 from here, that is 32. And this is 30 mm front and 32 mm backwards. Am I right? So let us check. Guys, are you clear on this? Front portion 30 mm. Okay. And rear portion 32 mm. Now our axis is exactly here. I stop here and let me understand if you people got it or not, or else we will see it again. Okay. So today, this is a new option what we use in pad itself. For the last few models, we use this pad, but we have not used the second limit. Okay. So first limit we define, and second limit also we define. All clear? Any confusion in this? You want me to do it again? Shall I do it? Okay, I'll do it again. I'm deleting it. So are you clear, guys, how we consider this sketch?
Yes, sir.
Okay, how we consider from the drawing, and what is the reason we considered here? All the theory I explained. Okay, so we consider axis here, and what is the dimension here? So the total dimension is 62. So I wanted this point. This point is 14 plus 18. So this is the face. So our axis system, we placed it here, exactly here. Okay. So from here, front side, how much is the thickness of the how much is the length of the part or width of the part? Okay, almost the part is coming here. Okay, this axis system is here. So this portion is 30 mm and this is 32 mm. Okay, that is what we calculated. Am I right? The backward portion is 32 mm because we placed our axis system here. So that is what we can see in our sketcher. Okay, if you get into sketcher, so now this pad is created. This pad is created at this location. Okay, at this face. Only this pad is created at this location, at this face. That's the reason we projected some of the pad backwards and some of the pad forward. Okay. Again, how to check the sketch analysis? Don't forget this. Once you finish the sketch, then you need to check your sketch analysis. It is closed and everything fine. Okay. And everything is green. That is what we want. Guys, are you clear on this? No problem. We will work 2 days on this. But you need to understand. Okay. And now I'm going to pad. I selected. Okay. And now, as the front portion is 30 mm as per the drawing, so I have given first limit as 30 mm. You can see limit 1, limit 2. So as of now, we have given the limit 1, say more, and then you will see limit, next limit here. Okay, this is the first limit and this is the second limit. In second limit, what is required for you? 32 mm. Okay, that's how we got this pad. Shall I proceed, guys? Is that okay? Let's see. Sometimes my system is problem. Let me save it. I'll say 1, 2, 3, 4 as of now. Okay. So after this, what is next important feature we can? So this portion is done. Okay, this bottom portion is done. Now we have to work on these 3 ribs as well as the cylinder. Okay, so now we can use we can create this profile, this for these 3 profiles. We are going to use new option today, which you are going to learn today. Okay, that I'll tell you how to do that. So now simplest thing is, let's finish this top one. Okay, so what is the dia of the outer one? 44. We already saw that. Okay, so let's get into this and just copy it. And what is this? Front view itself. Okay, again we are going to front view and get into sketcher. I'm just copying it. You don't need to copy it also, because we don't need any reference, because the axis itself is our origin. Okay, so simply create one circle here. And what is the outer dia, please? 44. Am I right? Please confirm.
Yes, sir.
And what is the inner dia?
26, sir.
Twenty-six. Thank you. Okay. So this also I'm going to say to a coincidence. Okay. This is done. So what is, and we can simply come out. And now tell me again, we are going to project it. Okay. So from here, from this center, again we'll go back to drawing and we'll decide. Let me check how much distance it is projected. Where is our face? Okay, where is our origin? And from there, how much it is projected? Now tell me.